ちょっと向こうに遅れるって言ってたらいいと思う。今もうスタートするんだどうですか。いつももうちょっとしかSorry, so the whole students register this class, but the rest of the two students not come here. So please decide to start or not now.
Hello, NTU.
Hello.
まあ、とにかく2人まだ来てないけど、始めていいかどうか。もう10時半じゃん。一応時間なんで、向こう待ってるんですよね。
Shall we start today's class?
Yes, please.
いや、でも筑波からなんですよ。
はい。じゃあ、大丈夫。今日一人だよね。
僕と NTU から2人。
じゃあ大丈夫。はい。
Good morning. Can you see my slide?
Yes, we can. You may start.
Okay, I'll start my presentation. So good morning. My name is Ryosuke Sugio, and I'm from NTU. I'm from Tsukuba University. So my topic is allergy cell disruption to extract allergy oil. So this is my references. I got an article from a university in UK. So this is introduction. Nowadays, like people are trying to shift the energy resources from fossil fuel to biodiesel because like we concern global warming because of CO2 emission, and biodiesel can be like carbon neutral resource. So nowadays biodiesel are getting popular. And when you think biodiesel, there are some kinds of the resources. For example, like palm oil or canola. But today I focus on allergy. So what is allergy? Allergy are the diverse group of aquatic organisms that have the ability to conduct photosynthesis. So allergy is not just a name of one species, it's name of group which conduct photosynthesis, and it includes seaweed or these kind of microorganisms. So why allergy is popular for biodiesel? Because there are some advantages. So first one is they grow fast. It takes only 30 days to grow. And second one is they fix much CO2. It can be used for like good carbon neutral resource. And third one is they have a high density of oil. It's about 20 times more than palm oil. And the last one is they doesn't displace land for food crops. Since allergy has high density of oil, we don't need much land space to produce allergy. So we can save our land for making crop. So when so since allergy has good advantage for biodiesel, what we have to do for allergy is we have to extract oil efficiently. So of course, the oil is inside of allergy cell. So to extract oil, we have to disrupt cell wall efficiently. we have to break the cell wall. So the objective of this research is to find which treatment is the most effective to disrupt allergy cell wall. And when they determine which treatment is the most effective, they consider about energy consumption or disruption ratio and sample volume of each treatment. So this is methodologies about materials. So first, they use this allergy, and they have 5 different treatments to break the cell wall. So first one is microwave, and second one is water bath, and third is blender, and ultrasonic, and laser. And before treatment and after treatment, they count how many allergies are not broken by microscope, and they calculate which treatment is most effective to break the cell wall. So this is the calculation. So D means allergy disruption percent, and V is gotten by sample volume divided by device volume. So it means how much volume of allergy can be treated with the device at one time. So it means like if the device is big, they can treat much allergy at once. So it's more efficient. And J means the applied energy per liter. So in this calculation, we can say that if F is high, the treatment is more efficient, and if F is low, the treatment is not efficient. So this is the result. As you can see, this is the result, and the laser disrupt the highest percentage of allergy cell. It's about like 96%. And the second highest one is microwave, and third is blender, and fourth is hot water bath, and last one is ultrasonic. And as you can see, each treatment has different shape of the graph. I mean, each treatment have different characteristics. So for example, about blender and microwave, the longer treatment time is, the less disruption ratio. Like the more, if the treatment time get longer, the disruption ratio is going to decrease. But on the other hand, ultrasonic, if the treatment time is longer, ultrasonic can disrupt much more cell wall. So this is the result about the F number. So as you can see, microwave and water bath has highest number of F. So we can say microwave and water bath are most efficient among these 5 treatments. So, but in the last slide, laser could disrupt over 95%, but the F of laser is very small. This is because laser consumes kind of much energy, and they can treat very small amount of allergy at one time. So that's why the F is going to be very small. So this is conclusion. In this research, they use 5 different devices to disrupt cell wall: microwave, water bath, blender, ultrasonic, and laser. And among these 5 treatments, they concluded that microwave and water bath are most efficient to break the cell wall. But as you can see in the graph, each treatment shows different characteristics. So that means each treatment has different potential to be improved. So, I mean, a laser could disrupt high percentage of cell wall, but laser consumes much energy and they can treat very small amount of allergy cell at one time. So if we can improve the laser if laser doesn't consume a lot of energy, and if laser can treat much amount of cell wall at once, laser could be very efficient method. So this is the conclusion of the research, and how to connect this research to my research. As this research focus on the efficiency of the breaking cell wall. So like when I start my research, I want to consider about 3E, that means environment and energy and economy. Yeah, we have to consider all of these three things, not only scientific techniques. So when I start my research, I want to consider about these three things. So again, this is the references. Thank you for listening. So do you have any question?
Thank you for your presentation. It was really good and well arranged. My question would be, I don't know if you mentioned it, but is algae oil currently being used now? And if it is, then what methods are they doing to extract the oil? Are they using these 5 ones, or are they using a different method?
Okay, thank you for your question. Now they use allergy cell in commercial way, but the allergy should be high density. Like we have to get allergy from. If the density of allergy is lower, we cannot get energy, right? So nowadays they are producing allergy in pool, growing in the pool, and they extract oil. But since allergy has much water inside, so they need to evaporate water to get only oil. So and then what they do to extract, right, in commercial way,
Yeah.
they use high pressure. In this research, they didn't focus on pressure. They use only physical breaking. But in commercial way, they use high pressure and sometimes chemical things to extract oil.
Did they compare the 5 methods with the current, in the paper that you reviewed? Did they compare that method, the high pressure method, versus the 5 methods that you mentioned?
In this research, they didn't compare. They compare only 5 treatments.
Okay, thank you very much.
NTU. Do you have any question from NTU?
Any question or comment?
Thank you for your presentation, and I would like to ask you if this algae will be the replacement for petroleum in the future.
Thank you for asking. I think it doesn't replace the fossil fuel, because nowadays we are finding new fossil fuel almost every month. like they discover like new oil, and if there are many oil, the oil price is not going to be high. Just I'm guessing. So, and in introduction, I said like carbon neutral is very important for global warming, but for me, I really don't believe global warming is really happening or not. So if fossil fuel is cheaper than allergy oil, people will use fossil fuel, I guess.
Thank you.
Any else question? Yes, Zoe.
Okay, thank you for your presentation. I want to ask how much does it cost to build 1 gallon of oil?
In this paper, they didn't mention the cost, but we can guess the cost from how much energy they use about each treatment. So like laser consume a lot of energy. So laser should cost a lot compared to other treatments. And we can think how much cost it takes when we introduce this machine. I guess each device has different costs when we buy, but we have to consider about the cost too. But in this paper, they didn't mention, so I will try to research later. Thank you.
Thank you.
Thank you for your presentation. Is there any chemical method to do this? Because you mentioned is a physical method.
Yes. In commercial way, they use, as I said, they use like high pressure or chemical method too. But yeah, in commercial way, they use chemical. But in this research, they compare only physical treatments.
Okay, what is the physical treatment advantage?
Sorry, again, can you say again?
What is this advantage compared to chemical method?
I guess if we can combine physical method and chemical method, it's better. So like we have to like research what is the best way to use what is the best chemical method and what is best physical method. And I guess in this paper they focus on just physical method.
Okay, thank you.
Thank you for your presentation. There's no comment and question from NTU.
Thank you.
And next presenter will be Guo Yunyuan from NTU. We sent our slide to you. Can you see our slide?
Oh, yes, no problem. Thank you.
对，我知道，我会对。
Aló.
Okay, you may start.
Oh. Good morning to you all. Today I'm going to present about the study on producing refuse-derived fuel using waste plastic film and sewage sludge. First, I'm going to explain what is refuse-derived fuel. Refuse-derived fuel is a fuel from domestic and business waste, such as garbage, waste paper, waste plastic, in which then this fuel is used to produce energy. So, in the agricultural area they have a lot of plastic waste, and every year it increases. And an example is the plastic mulch, in which is used in the mulching production. The mulching production, or the plastic mulch, is used to suppress the weeds and conserve the water in the crop production. And mostly this waste plastic film is usually discarded in landfills or incinerating, resulting in land or air pollution. Humans, they also produce a lot of sewage sludge. The sewage sludge is the final solid component produced during the wastewater treatment, and then most of the sewage sludge then is discarded into the ocean, producing also contamination. So the objective of this paper is using waste plastic film and sewage sludge to produce this refuse-derived fuel. So, and to produce this refuse-derived fuel, they need to analyze the heavy metal components and the heating values of these two components, because they need to analyze the heavy metal components to prevent the air or soil pollution, and they need to know the heating values, because the heating value indicates the energy available in the fuel per unit mass. And also they need to determine the optimum mixing ratio between waste plastic film and sewage sludge, which is bigger than 6,000 kilocalories per kilogram. And for the materials, they are using plastic waste films from seven different parts. And for sewage sludge sample, they were collected from 5 different sewage treatment plants. And for the methods, for the water content, they use was measured by oven methods. The weight of the ash and combustible components was determined after burning it at 850 degrees for 3 hours. The heavy metal material components were measured by a special analysis institute, and for the analysis of the elements, they used an elementary analyzer. For the high heating value, they use a bone calorimeter, and for the low heating value, they use this equation. The difference between high heating value and low heating value is that for the high heating value in the combustion product, it exceeds the liquid water. Meanwhile, for low heating value, the combustion product, it exceeds the water as vapor. And the results and discussion they use, as you can see in the above two charts, there are the results for waste plastic film and sewage sludge waste. And in the third one is the standard values for refuse-derived fuel. And what I can say, this is for the sewage sludge. Their moisture content is bigger than 10%. So to reduce this moisture content, they need to dehydrate the component. And as you can see, the low heating value for sewage sludge has a negative value, which means they need it needs heat to be burned out. So they did it again with 10% of moisture content, and they got a bigger value for it. And for the heavy metal components analysis, you can see in these results that the heavy metals for waste plastic film and sewage sludge are below the permitted limits. So this means that these both components can be used as raw material for refuse derived fuel. For the element analysis, we can see that the sulfur doesn't have any content. So this means there is not expected sulfur dioxide to be released into the air, but we can see a large amount of nitrogen, which it suggests that nitrogen oxide are expected to be emitted. For the mixing of waste plastic film and sewage sludge, the proper ratio is 50-50% ratio because it is bigger than 6,000 kilocalories per kilogram. Because if the 50% of the plastic film is included in the mixture, the possible achieving heating value is bigger than 6,000 kilocalories per kilogram. And for the conclusion is that the heavy metal components were below the permitted limits, so they could use these two materials as raw material for refuse derived fuel. There was no sulfur content. However, there was nitrogen oxide gas will be emitted from the fuel, and to acquire an adequate heating value required for refuse derived fuel, a 50-50 ratio was found to be desired. And these are my references. Thank you.
Thank you for your presentation. Any question or comment? No? Next thing, who wants to say something?
Just a quick comment then. I just I like your presentation, but I'm not sure to understand well the thing about the plastic film. I mean, what was the purpose exactly? Because I didn't.
Can you repeat the question, please?
I just didn't understand very well the purpose of the plastic cover.
Oh, it's because because this is a paper from Korea, so they found that there was a lot of pollution in Korea, so they wanted to find some renewable energies for it. So they used these two components to find to produce a more renewable energy for them.
Thank you.
You're welcome.
Any other question?
Thank you for your presentation. I have a simple question to ask. Why do you choose this topic?
Why did I choose this topic? It's because I'm interested in this topic, especially with biomass. So I wanted to search something related with biomass.
Thank you. There's no question and comment from NTU. How about UT? How about TU? I'm sorry.
Good morning. Thank you very much for your presentation. So I'm not really familiar with the refuse-derived fuel, but I want to ask, since you already mentioned that you're interested, they were interested in making a new renewable energy source. Is this better, maybe in terms of cost, in comparison to already established renewable source like solar power or hydroelectric power?
I don't know much about the field, but what I know is for solar panels and for wind turbines, you need a lot of money to construct them. But for this refuse-derived fuel, it maybe be less costful than the other two, and also is because you every day have waste, so you always have these, how do I say, these sources. How do I say this? We have these sources. What I mean is that for solar and for wind turbines, you depend on the climate, but for this refuse-derived fuel, you depend on the waste of the people, and we every day we produce waste, so maybe is better, in my opinion.
I have another different question. I'm not sure because, yeah, as I said, I don't know much about refuse-derived fuel. How do they make the fuel out of the waste exactly? Do they burn it or other methods?
They burn it.
Oh,
Oh,
okay, thank you.
you're welcome.
I have a question. Thank you for your presentation. I guess one of the biggest plastic waste is plastic bottle. And in your research, you use plastic film. But do you think it can be used with plastic bottle and sewage?
I don't know exactly if can be used for plastic bottle because they are made from different plastic. In the film, they use polyethylene. Meanwhile, for plastic bottle, I don't know the name of the plastic, but it's different from the plastic film. So maybe I don't know exactly if it can be used for plastic bottle.
Okay, thank you.
Thank you for your presentation. This may, I'm not sure it was mentioned in your presentation, but do we need a big facility like power plant to producing energy from waste?
I'm sorry, can you repeat your question?
Do we need a power plant to produce energy from waste garbage?
You said we need
Power plant.
power
a
plant.
Big
Oh,
facility.
so your question is if we need power plant to produce this kind of energy?
Yeah, yes.
Yes. Mm, may power plant. Mm. Mm.
I think we can do that in house or any kind of building.
Like, maybe not in every house because you need some kind of machinery to burn this waste. So maybe you need a bigger place. So in houses could not be that useful. You need bigger places to be incinerated this plastic, this waste.
Thank you.
You're welcome.
That's all from Scuba.
Okay, thank you. And next presenter would be Yijing Wu from NTU.
Good morning, everyone. I am Wu Yijing from NTU, and today I'd like to talk the development of yield and harvesting time monitoring system for tomato greenhouse production. And this is my context. And tomato is one of the most popular vegetables in the world. So getting the information about the yield and its analysis are important for planning subsequent cultivations and improvement productivity. And we know that growing tomatoes need a lot of labor and help to have a lot of production. So using monitoring system can easy to improve production and labor management. Or if grower wants to plant new varieties, use the monitoring system can minimize risk and challenge more new variety. And this study produce the monitoring system. It is composed of the barcode reader and electric balance and microprocessor and the card. The barcode will hug near the trunk of the plant. This is the flow of measuring and sampling of yield and harvest time. So if I was the worker, I will first record my name and push the start button and use the barcode reader to read the barcode of the plant and harvest the fruit and put fruit on the balance and push the button to measure and save. Because a plant doesn't have only one fruit, so the step will be repeated many times. Yes. And this figure is the experimental greenhouse arrangement. A plant distance was 25 centimeters. The row width was 1.5 meters, and 36 plants of one variety was planted on the same road. The tomato variety used in the experiment was DR03103 and Momotaro Yuko, Tomimaru Muchu. Okay. And this experiment was also discussed the yield and harvesting time in relation with greenhouse climate. The reasoning behind measuring temperatures of the greenhouse is that the temperatures and accumulated temperatures of greenhouse interiors are primarily factors affecting timing and blooming, fruiting, and the yield. Yeah, this is the yield map, and the total weight of harvesting fruits per plant indicates productivity of plant. So we can see this one. Tomimurumuku is the highest. And these 4 plants for DR03103 is their cultivation was stopping owing to the plant disease during the early cultivation. And this is how harvesting time map. In picture B, there is no large difference between average harvesting per fruit in 3 varieties, and the average harvesting time indicates laborers harvesting performance, including working and difficulty of harvesting. And this is relationship of number of harvested fruits, weight, and total harvesting time. I comparing 2 variety, DR and Momotaro. And the figure shows that the total harvesting time increased as the number of harvested fruit are, and the weight increased in all varieties. And we can see that the coefficients of number of harvested fruit and total harvesting time are higher than those of total harvesting weight for all variety. And it indicates that total harvesting time depends on the number of harvesting fruit and can be predicted by measuring the number of harvested fruit more precisely than total weight of harvested fruit. Okay. And this is the relationship of greenhouse climate. This experiment was from December to June, and since day 48 is nearly February, the outside temperature start rising, and the inside temperature start rising too. Okay. At day 103, when the outside and inside temperature rising, all varieties of harvested fruit reach a peak. It is considered that fruit ripening fast by greenhouse inside temperature rising, then the fruit was increasing too. Okay, we can see the picture C and picture B have similarly trend of the harvesting time. It is because harvesting time has high relationship with the number of harvested fruit. And picture D, was found that the average fruit weight in the day from 50 to 100 were lower than other days when the greenhouse inside and outside temperature was rising. And this is my conclusion. The first is this research depends upon a monetary system that can be used in a greenhouse environment to investigate and analyze yield and harvest time. By using monetary system, we can get the yield map, harvesting time map, and relationship of greenhouse climate, yield, and harvesting time. And the yield map, it was considered that the information from yield can be useful for improvement cultivation technique, production management, and installation of new variety. Harvesting time map, it can indicate the amount of labor for harvesting, and it can consider that labor costs can be estimated easily, and growers can manage harvesting labor easy. The relationship of greenhouse climate is by prediction of the number of the fruits and harvesting time. It is possible for growers to adjust harvesting day and avoid concentration of harvesting labor. And this monetary system can be used not only for tomatoes, but also for other fruits and vegetables. And others say in the future, they will have to improve the user interface to develop the commercialization of monetary systems. And this is my presentation. Thank you.
Any question or comment?
Thanks for your presentation. And could you give a shorter explain about how your monitor system to get information, how to get information or process to for your tomato?
How to get it? It has the microprocessor to read the information you get from the barcode reader. Maybe you would just
I think the barcode reader will go to read the barcode with clip to know the data of the maybe yield and the other information of this.
Okay, thank you.
Sorry.
I had a quick question about the process, because the whole purpose of your presentation is to analyze the time we spend to harvest. But at the end, do you know there's any there's any improvement to do in harvest in terms of time to harvest? I mean, can we improve the time to harvest at the end? do you think we can improve the time of harvesting?
Yes.
All right, thank you.
Any question or comment? Okay, no comment and a question from NTU. How about UT?
Just comment. I have just comment. So I think this method or this like technique is very good for harvesting, since like Japanese farmer, the number of Japanese farmer are getting smaller and smaller. So we have to harvest efficiently. So I hope this machine will help to harvest. Yeah, it's just comment.
Okay, thank you.
For me, my question is, since you are this paper is focusing on having an automatic harvester, is that right?
Yes.
Yes. So one major concern with automatic harvester, especially with crops, is the efficiency with harvesting the crop without damaging it. Did the paper mention about damage to the crops during harvesting?
Can you repeat again? Sorry.
My question is, did the paper or the researchers mention about any damage to the crop while using these machines?
No.
So you mean the machines perfectly harvested the crops? Is that right?
Yes.
Does this machine collect by itself?
I think
It's not.
I don't think so.
It's not collect.
Human collects and they put.
along with Lucy.
So it's
Yes,
not automatic.
yeah.
Wait, is the machine getting the tomato from the plant, or is a human getting the tomato and putting it in the machine?
Just harvest the tomato on the balance. And
who harvests the tomato from the plant?
I think human to harvest the tomato,
Yes, yes.
and this machine just to collect the data of yield and something else information. Yes. So yes. So I think this machine is used for let farmer knows maybe which kind of variety is more suitable for this farm. I think so. Yeah.
So it's not really an automatic harvester per se. It's just like an automatic fruit analysis, like fruit weighing machine. Is that right?
Yeah. Yes, it's right.
Okay. Thank you. Then disregard my question. Thank you so much. I'm sorry also.
Yeah. Thank you very much for your presentation.
Thank you.
Yeah. So finally, so the agriculture machinery and information acquisition system is very expensive for the farmer, right? normally the farming so needs a lot of cost for the machinery and the fertilizer and so on. Okay. Yeah. So my question is how much the cost finally can be reduced after introducing these robotics and data acquisition system. How much the cost can you reduce?
It didn't say in this research, but I think this loss thing will not be very expensive.
Still expensive. Yeah. Please check that kind of the information. How much the cost of farming is required? Yeah, I think that's your assignment. Okay. Okay. Thank you very much.
Thank you.
That's all from Scuba.
Oh, okay, thank you. And we have no presenter today, so maybe we can we can say bye bye.
Thank you.
Professor Noguchi, do you have any conclusion or comment for this class?
Thank you very much for the good presentation from the students. So I requested all students please study the around of the research. Okay, research is one of the topic, not the whole. If you discuss about the present your research, you have to know the related information, farming or energy and so on. Okay. Not only prepare your presentation, but also the other general information.
Yes, I agree that. Thank you. So maybe we bye bye.
Thank you.
Thank you. Bye bye.